when you come back from a long day at school and your mum asks you whether you want something meaty for dinner, you don't expect her to present you with a question where you're asked to find the curl of a vector field, because this is a pretty meaty question. The first thing that we need to do is define what a vector field is. And it's where F equals Pi plus Qj plus Rk. And the curl is nabla with the cross product of F represented in this little matrix. So you're going to get d over dx, d over dy, d over z, p, q, r. So there's lots of stuff to do here. We first need to find out some differentials, then we're going to solve this matrix, and then we're going to substitute stuff in to be able to get our final solution. So firstly, let's define. We've got p, which is x squared y, q, which is e to the y, and we have r, which is x sine z. So we want to calculate the determinant of all of this, and the determinant, if you aren't familiar with calculating determinants, don't know why you're doing this. However, I've got videos on 2x2, 3x3, 4x4. You can look at them, but you're basically going to pick your column. So let's say we're going to do the I column. You're going to cover this, you're going to cover this, and you're going to get, basically you want your dr dy minus dq dz. And then you're going to repeat that for everything. So your nabla times f is going to be I dr dy minus dq over dz. And then in calculating determinants, you're going to have plus minus plus minus plus minus plus minus plus. So you've got to remember that this is now going to be a minus. Again, watch the determinant video if you're unfamiliar on how to do this. It's going to be j, and then dr over dx, and then dp over dz plus k dq over dx minus dp over dy. So we've got all of our different variables that we need to now differentiate. So let's do that. So let's begin. So we're going to have dr over dy. So that's this. There's no y terms, so that's 0. Let's now do dq over dz. That's going to be this in terms of z. There is no z, so it's going to be 0. Let's now do dr over dx. We actually have an x here, so we're going to use partial derivatives. And so that's just going to be sine z. And then we're going to do dp over dz. There is no z term, so that's 0. And then let's do dq over dx. And that is going to be 0, because again, there is no x term here. And then we're going to do dp over dy. And we actually have a y here, so the y disappears, and we're going to get an x squared. So we're doing pretty well. We can now rewrite out this. We're going to get I 0 minus j sine z minus 0, and then plus k 0 minus x squared. So obviously let's get rid of all of our zeros. So we're going to now get sine z j minus x squared k. So we've done the cross product of x, yz is going to be 0I minus sine zj minus x squared k. That there is the curl of the vector field, but we need to now figure out whether it's conservative or not. If something is conservative, the nebula time cross product of f should be 0, so that is conservative. And that means if you have the nebula with the cross product of f, it does not equal 0, then it is not conservative. A conservative field has no circulation or rotation. So a really good example of a field like that is gravity. So in this instance, it does not equal 0, so therefore it is not conservative. Done.